Who is a software engineer and what do they do?
A software engineer is someone that uses computer programming languages, skills, methods to write software that would solve some sort of real life problem. So a lot of that is involving problem solving skills and um, organizing things in ways that will work best to run on some sort of computer system to solve a problem or address some sort of task.
Where did your passion begin in your childhood for computer science?
Uh, well, I think it was probably when I was really young, around 8 years old, probably, when I first got an Atari and was playing Pac-Man games, and just I was always, you know, into games and understanding electronics, and I think watching Star Wars, it also was one of those things that just turned me on to science and science fiction.
What about your hobbies? Did you try and build something yourself?
I took a lot of things apart. I mean, I think that was probably one of the things is I wanted to understand how things worked. And if you ever had an Atari joystick thing, that would always break. And rather than just having to get another joystick, I would take them apart and try to fix them because there were screws. So I knew that I could take it apart, and I would get a lot of usage out of doing that multiple times and figuring out, oh, this is the little button that I press that pushes this little circuit, and playing around with that. I was pretty much the family's IT person. Every season change, when we would have the time change, I would have to go to different grandparents' houses and reprogram all their VCR clocks because apparently I was the only one that knew how to do that and enjoyed doing it. And whenever anyone would get some type of new electronics, they'd say, "Oh, let's call Shane over and have him figure it out." And I enjoyed doing that because it was, obviously fun to be able to spend some time with family. But I just loved things that had buttons and lights and had to be connected and understanding how it worked.
Your educational journey started at WPI in Worcester, Massachusetts. How was that like?
For me, it was a really great experience. It was 500 miles away from my home where I grew up. So that alone, I think, was one of the things I was excited about, is just feeling like I was getting out into the world. Um, as far as the college itself, it was excellent for teaching technology, and we had multiple projects that we needed to do, which I thought going in sounded really interesting to me. You had focus in a humanities subject for 1 year, and then you had these other bigger projects that you needed to do in order to graduate. And they really wanted to emphasize how technology impacted society. That was one of the big things that they were trying to establish within the engineering students. Is it's not just all about what can we do. It's also about why should we, and is it a good thing, and what is the impact, and because there's a lot that we can do. If you really put money and research and time into figuring out how to do something, it's not much that can't be achieved. But it's also, hey, is this really what's going to be a good thing to do? So I thought from that aspect that the college sounded very interesting to me, and my years at WPI were filled with a lot of learning, a lot of studying, a lot of fun, and a lot of friendships that I still have. So that was really good.
Was there any particular reason why you chose WPI?
This is gonna sound funny, but yeah, I mean, honestly, I had only considered this technical school that was right nearby where I lived growing up, which was an excellent school, but it was very large. Um, and I'll mention it, Virginia Tech. They're great. Have a great engineering school, but it was pretty much where a lot of the people who I grew up with were also going to be going. And I think at that time I was just really looking for something that was different, something smaller, something more focused. And I got this brochure from WPI. I had never heard of them, weren't even on my radar. And they said, we have a nuclear reactor that can power a light bulb. And I had no interest in nuclear physics, but I'm like, well, that's kind of cool. Oh, they also offer electrical engineering. That's what I'm interested in. And so it turned me on. I did some more research onto the college, and they were a very high-ranking school in the Northeast. I spoke with my best friend at that time, who was also interested in engineering. He was looking at aerospace engineering at that time. The same college had programs for aerospace engineering. So he and I decided that's where we wanted to go. And we applied and were accepted in. And at that time, it was something that, it could be more affordable. They offered computer science as a major, electrical engineering as a separate major. And at that time, I was really thinking electrical engineering, that's the interest I had because, like as I mentioned, I liked to take things apart. I liked when things broke, I would unscrew them and look at circuit boards and not necessarily know what I was doing, but I would just try to understand it and go from there. So for me, that was the draw was I wanted to understand how these circuits worked, how they could be put together to do these cool things. Like how does a stereo work? How does that sound come out? That's pretty amazing to me. And the lights on the front of it, that's cool. I want something with more lights. So if I can learn how to make these type of things, that to me was what was my interest at that time.
Yeah, there is a magic to it. Um, what about math? Was it was it hard?
I will say in general, yes. I think for myself, math was a subject that I did well in. I understood the concepts pretty well. English, not so much. I didn't do well in English. Uh, but I could wrap my head around math. And I had really great teachers in high school that I think prepared me for college math courses well. The course work was pretty heavy. But, once you got through your freshman year at WPI with your math courses and you got through differential equations, from that point you could sort of move on and not have to deal too much with just math courses. It was then at that point, hey, now we're going to actually apply some of the math that you learned to these other aspects of electrical engineering and understand why we needed that math to solve these problems. Like what size of a capacitor do we need? What is going to be the behavior in this system over time? And here are the math tools that you now know how to use. Let's work through and apply them so that we can determine how to put something together that's going to do what we want it to do.
And there was this particular point where you got to software engineering, like to actual coding.
Yes. So my freshman year, again, was mostly like, your basic math and physics. I did start taking my humanities classes. Sophomore year there, you start to shift into your major classes, the things that you wanted to focus on. So that's where I started taking like those basic microelectronics classes and fundamentals of electrical engineering. And then I think somewhere around junior year is when probably after you take logic classes. So with electrical engineering, you learn a lot about logic circuits, how and or NAND and different type of operators can be placed together in sequences and series to perform some type of function on different inputs to get your result. That logical thinking is something that I enjoyed doing, and a lot of computer programming is thinking in logical ways and thinking in steps of how to take some input and then put it through a system and get some result. So I started taking some classes. I had grown up, had some programming classes when I was in middle school and in high school. So computer programming was something I had some experience with, I was familiar with, and I enjoyed. So my thought was, all right, yeah, I'll take some of these computer classes, because looking at the future of careers at that time, this was early mid 90s, it was becoming kind of clear that there were a lot of careers and job offers in the computer science field and computer programming, software development. So those were skills I thought I could benefit from after graduation.
Would you say that electrical engineering is harder to understand than learning to code?
In my opinion, I do kind of feel that the concepts of electrical engineering were more difficult than learning how to program. Um, and that might just be the way in terms of which my mind works, but there seems to be much more flexibility with computer software that you don't have with hardware. Um, I remember I was taking a VLSI class and thinking it was the coolest thing, but it was so complicated on how to just, you know, create these little pieces of silicon and place these components on this virtual circuit board in a way to simply add two numbers. You know, there was just so much involved that you had to understand, and then even if you understood those top level concepts, you had the real life underneath it that needed to be considered. Like, you can't put these two etches too close together because of the conductance between and interference between signals that go between these different channels, and all of that you have to keep in mind. So there's a lot with electrical engineering, but you can break down electrical engineering into many different other subfields as well. And I think that was one of the things I started to learn too, was to actually have a job in electrical engineering and let's say be someone who designs hardware. You're going to have a very, it seemed to me that you would have a much more focused job that you were looking at doing. Whereas with computer software, if you had those skills and learned computer programming, you had much more flexibility, I thought, in being able to apply that to all sorts of fields in technology. And if you were to go and look at software engineering jobs right now and just see, there's just so many fields that are looking for software developers. You have medical, biotech, energy, telecommunications. It runs the gamut. You know, any website development is also under that umbrella of computer science. So it's just such a versatile field that I thought at that time, all right, this is a good path for me to take if I'm not clear yet on where it is that I necessarily want to go.
Was there any particular graduation project that you had to do?
Yes, at WPI, one of the requirements to graduate was to do your master's qualifying project. So typically, most students do this their senior year, and it encompasses your entire year pretty much. What I did was, with another friend of mine, we developed the software for this micro mouse robot. We had chosen this project because it seemed interesting to us. It was in the robotics realm, and it was involving aspects of both knowledge of how circuit boards and electronics worked, but also how to program them at a low level, but also at a higher level, at an application level, to be able to solve some problem. So the idea was, you had this little robot, you put it into a maze that was, I think, 16 by 16, say, squares big. And its job was to start in one corner and, with any type of wall configuration, find where the middle of that maze was. and it had infrared sensors to detect the walls. It had little shaft encoders on the bottom to measure its distance that it traveled. It had these independent motors that could be operated to move it along forward or backwards. So all of these things were involved in our project. We had to come up with the program for it to learn. We had to come up with we had to do a lot of problem solving because of what we were given. It by itself didn't quite function perfectly. So there was a lot of problem solving that had to be done with that.
How did the mouse understand that it's in the middle of the maze?
It had to essentially keep track of where it was. It only knew that it was starting in a corner, and it knew how many squares were existing in the maze. So we built software that basically represented that maze in its memory to like identify each square, and then it would, as it traveled along, leave these little breadcrumbs, basically almost like a stack would be in a program where you call into one function and another function. So it would be able to backtrack. So if it were to go and explore something, it's one square, and it sees, oh, there's no wall in front of me, and there's no wall to the side of me, which way should I go? That would be an algorithm that we would choose as to what might be the most optimal direction for it to pick. And it wasn't always the case where it was most optimal for it to just head toward the middle in a straight line. And this had to do a lot with the limitations of the hardware that we were using. In our case, that mouse could just go one square and stop, one square and stop. It didn't have to be continuous. So what we had found is whenever we tried to slow down, because it needed it to slow down, the infrared sensors weren't that great. It actually needed some bit more time to identify walls. And it also needed adjustment as it moved along because it had the two wheels on the side that were independently controlled, much like a wheelchair. And if you imagine when you go to like Walmart and you get that shopping cart and the cart has that one wheel that goes all wonky on you and you can't keep it straight. Well, it had similar issues with these caster wheels. No matter what we tried to do to make that adjust, just the imperfections in the maze board alone would cause it to skew. So we had to write a separate sort of algorithm for each time it would move for it to sort of self-adjust and stay centered as best it could. So it would basically determine like, hey, if I have a choice of going straight versus going and making a turn, I'm going to have less error if going straight is of equal good chance of finding the center. So that minimized the number of times it would have to make these turn corrections because those were challenging, making the turns. Also, it had little rubber bands that we had to wrap around each of these metal wheels. Again, we were using hardware that had been provided to us from a former project, and they did a great job of putting it together. But it was another group of students, much like ourselves, that put this hardware together, did the best they could with what they had, and some of it just didn't work. And the chip itself that we were using had issues. So one of the things we ended up finding was that the motor on one side just didn't work. We had to call this guy at Mitsubishi and get him to send us specs over to show us how these different registers were on the pins of that microcontroller. And the circuit board that had been laid out for us that used those pins, we had to like etch out one of those connections and hardwire and jump it so that we could reuse a different register for that same purpose. And this was all stuff we just had to figure out. We had an advisor, and that's the way that they designed that program. It's like, hey, this is your goal. You're going to face a lot of challenges. Figure it out. And, I was working with one other guy on this project who was a good friend of mine while in college. And, we busted our butts on getting this to work. We were really proud once it actually was able to find the center. It did it a few times. It wasn't consistent, but we were happy with it.
I imagine you were also very limited on the memory that you had.
Yeah, I don't recall the size of that memory. I want to say it was probably like uh, maybe 128K. It was very small. These were specialized chips. Might have been 256, but they were specialized chips to be used almost for simple electronics that you might find in a car. Something that might control your windshield wipers, and those type of applications. It was versatile, but it was limited in terms of how much programming you could put onto it. We actually had this daughter card that we would, because one of the other limitations is you had to burn your code into this microcontroller. It was a process, right? It wasn't just dynamic memory that you could load in, and like you would on, let's say, your laptop. You open up a screen on the browser. You can go to a website that you can code language in and write your code, tell it to run. You see your output. Yay. Everything's great. No, this actually had where we could write our code, save it as a file, hook it up to a cable through, oh my gosh, one of one of the output ports of the computer, strapped onto this daughter board that had a separate memory attached to it that would then be read from the mouse. So we could basically had a switch that said either read from this daughter card, which we again had to like strap onto the top of the thing, or read from the EEPROM. And because of there being so much development that we had to do, like trial and error development, it made sense for us to keep that daughter board attached so that we could adjust our programs as needed as we were figuring out problems. But the fun thing was when we stopped and we were like, oh, we've got this. It runs through the mouse maze great with the daughter board on top. Let's load it onto the EEPROM now and remove the daughter board. Well, that changes those variables now. With now the mass of that robot is a lot less because it's not carrying this other daughter board on it. And that also had an effect. So that whole experience, I think, was good as learning just how to deal with problems as they come along.
Yeah, we also had to construct a mouse-like robot to run through the maze, but the difference is from what you did back then, what we did now, of course, is that the hardware is much better, and you can imagine that the wheels and the infrared sensors work almost flawlessly, and the adjustment speed is very good, and I had to code an algorithm that actually would help the robot to find a way out of the maze without having a map. So if you just throw it in, and it doesn't matter, it doesn't have storage memory. It just browses. Yeah. And the point was to make a code that would not end up the mouse be looping back and forth in the same hallway or whatever. It always had to explore and find the exit eventually without looking backwards. That was an interesting experience. I cannot imagine how would you burn code like you did. But with having technologies changed so much and that you can actually implement, I would not call that a light algorithm because you have to do a lot of calculations on the go to understand, to store your movements, to calculate options, to read the sensors and all that. It's I do believe it's more heavy memory-wise. But yeah, it's amazing that you had to go through back then.
Yeah, we wrote that in C, and again, it was just interesting project to work on with dealing with all those little real life things. Like if it were just to create it and solve that problem virtually, the project wouldn't have taken very long at all. It would have been, like, hey, this is something you could probably wrap up in a week or two. It's virtual. Once you start actually putting real life into it, then um, that's when things you really have to consider all these different type of air conditions, all the possibilities that could influence something's behavior so that it's not ideal. And that's really what doing real life software development is about. Is you have these lists of requirements to come in, and you're like, all right, well, we can meet those. We can design it in such a way. But those requirements are never full, and never how things actually get used when they're deployed. There's so many different situations that'll occur that you have to account for and be able to look ahead at and accommodate before you really deploy it in those scenarios, because otherwise you're going to provide something that it's going to run into an error condition and it's going to fail. And it depends on where your application is, but obviously if it's that you're developing software that monitors someone's life systems, like their pacemaker or some other type of electronics that's in the I mean, that's life and death that you're talking about. So it's things you have to really put a lot of thought and error handling and tolerances in.
I was lucky enough to do the code in MicroPython, not in C. I imagine it would be a different
interactive
experience.
programming is great. You get
Yeah.
you see what's going on right as you do it.
Mm-hmm. Last question on the robot, just a really intriguing topic to me. Did it have a battery or?
Yeah, I'm trying to remember. It was like a lithium cell battery. That itself was kind of problematic too, because that technology was pretty new. So what we found out, it had a lifetime of charge that was not even.
That's what I was implying, because if you have a battery life, especially back in the days, I would assume it was not very long on these kinds of robots. You would have to also calculate the lifetime of the battery and the physics that go into the consumption.
Right, right. And I believe this is going back quite a few years, but that daughter board that I mentioned, it had power that it could be provided at the time. So if you wanted to have like a umbilical cord to supply power, you could. That posed its own challenges, but it did give us more flexibility if there was a specific aspect that we were trying to work on. Like, for example, just verifying and calibrating our infrared controllers and seeing that we can move one square evenly and correctly. We might attach that so that we're not drawing the power off of that lithium battery, because again, it would cause issues. It might have had a lifetime, let's say, of 2 hours, maybe, but what we would find is after an hour, things could start behaving not the way we expect them to behave, because of the way in which the power supply itself wasn't being consistent, and just issues there with the hardware and the electronics. So if you had a glitch where the power didn't quite get to that infrared controller at the same amperage as the others, so you might get a different reading than you would see on the same infrared controller on the other side. Or over time they just drained those controllers down so that they didn't provide the same results. That was something we never tried to program around. We just dealt with that restriction as best we could by okay, we can only run it this long, and then we have to charge the battery. So that impeded progress, basically.
This is where the problem solving comes in.
Yeah.
um, you graduated. You got your master's degree after you got your bachelor's degree, right?
Yes.
What was the reasoning behind that?
The reasoning behind that was, at the time, WPI, and they believe they still have this, is they offered a BSMS program. So as it was approaching my senior year, I started to I was taking more computer science courses. I was taking some networking classes because those seemed very interesting to me. And some of those networking classes were actually things that were offered at that master's level. So one of my advisors had said, "Hey, well, I know that you've been doing some senior coaching with some of the classworks. Have you considered pursuing the master's? We have this program where if you take these classes at that master's level in your senior year, they will apply to credits on both programs. What that allowed you to do is basically get your master's in a shorter time. You could do it in 1 year's time after you get your bachelor's. And back then, I was like, you know what? That sounds good. I like it here. I'm happy. I'm comfortable. I enjoy the teaching, so I applied for a teaching assistantship and was awarded that. So WPI was going to pay for me to continue as long as I, adhered to being a teaching assistant there, which I was all for. I thought it would be a great experience, and it was. It was a lot of work. It was a lot of dealing with people that were frustrated with things, but those experiences, I think, really helped me to determine is this something I enjoy or not? Because literally one of the thoughts in my head was at some point in time I might enjoy teaching at some level, and I can say I enjoy helping people, but I don't think I could be a teacher. That's a lot of work, and I don't think teachers get enough respect. The ones that actually do it and do it well and are still doing it after so many years at that same level. Just because you see all sorts of this, you see the same type of issues. And I only learned this in 1 year because I was I was helping and assisting in the same class. So each term you would see new students come in, but they would all have the same frustrations, same questions, same issues, same meltdowns, So it was like, wow, I can't imagine doing this for middle school kids.
And you run the lab.
Yeah, I was running lab, so I was preparing the lab work, whatever supplies were going to be needed, and then I was in the lab to introduce what the goals were, help them understand what they needed to do in that time period, and just be there to answer questions. And there were definitely a few moments where people would come to me and just utter frustration and break down because they didn't know what they were doing and they were stressed. And those are the human elements involved in that type of situation. And I felt like that was something that I could help with, but I mean, at the same time, was not prepared for. I was prepared for, hey, here's how you go from this to this to this to this. Go do this, and if you get stuck, come back. But I enjoyed that experience. I enjoyed the person I was, teaching assistant. I shared a room with this guy, and he and I would just goof off pretty much the entire day as we were grading papers, throwing Nerf basketball in a hoop. So it was like a fun moment in my life.
Could you take us through your first job after you graduated?
Yeah, I mean, my technically first job was with a company called Cabletron. That was the first software development I had. I ended up doing that in like a summer period and extending it while I was still in school a bit. Um, I was working on developing SNMP MIBs, which were just this like library that you could write. There was some sort of well-defined library to run on networking systems throughout your your company's network, so that people could log into it, manage it, look at statistics, that sort of thing. It was pretty straightforward work. Um, that was me just sitting in a lab in front of a computer, sort of cookie cutter writing code that I thought, well, really, this isn't a lot much to this, but it's a lot of work. It was a lot of, let's say, paperwork to get through because these libraries were very, very large. Um, so I looked for ways of trying to improve and be able to do that faster by maybe writing some scripts. But because of the variables and variances within those MIBs, it didn't work well to try to write something to do that. At least I didn't have the knowledge at that time to understand how. So my solution was, hey, what if friends of mine also did the same job and we could bang it out much quicker and get all these MIBs developed? And at that time, like, yeah, sure, go ahead. If you know people, sure. So I ended up having 3 of my other friends that I was uh, at that time in the fraternity with going up to Cabletron, and we just sat in a lab listening to Metallica songs and writing MIB code, which
That
was
sounds
fun.
awesome.
So that was my first job. After I graduated, though, well, I should say the transition from my master's to work was more of a realization for me, where I was working on a master's thesis, which wasn't in. I just wasn't into, and it was somewhat struggling with. I enjoyed the teaching assistantship. It was taking a lot of my time. I enjoyed the classes that I was taking for the most part, also taking a lot of time, but really putting a lot of work into this thesis was draining to me. I had already done that MQP project on that robot, which I enjoyed thoroughly and spent a lot of time doing, but just wasn't getting into the thesis. A, a career fair occurred at WPI somewhere, I think, in January of 95, and the company Digital Equipment Corporation was there, and I spoke with someone, basically did an interview, and they're like, hey, you know what, we'd really, you've got a lot of skills already, we could really use you, we'd like for you to come work for us. And here's the thing: is we know you don't have your master's yet, but we have a program. We would pay for you to complete your classes, what you need, and you could start work for us. How does that sound? And I thought about it for like, I don't know, a minute, and said that sounds awesome. And started at that point looking at what it would need in order for me to change from a thesis option to a non-thesis option, how many courses that would be, and how did it extend out my graduating date. But that was the path that I chose, and I went to work there at Digital Equipment Corporation, still doing networking, telecommunications field software development. But at that time, I was really actually doing some coding and saying, here's a feature that we need to support in this device, and we need it implemented. Here's the spec on how the protocol is meant to work. People have already, architected this at a standards level, but we need to write the code around it. So here, can you do this? And that's like my first assignment when I was working there at Digital, and I enjoyed doing that a lot. I felt like at that time in my life, I was like in need of, yeah, this stuff is great. Show me more. Yay. And I had this sort of 18-month cycle, it seemed, where after 18 months, I was like, what's next? And so I went from Digital after 18 months to another networking company, and was ready for what they had available in next challenges. And it just kept exposing me more and more to different aspects of networking and the protocols that are used to route your packets through the internet. So, and then that's basically still where I am at in my career is in that telecommunications networking space.
In that particular field, in your particular example, would you say that hardware always goes side by side with software?
Not anymore. I
But it
mean,
did back then.
back then it definitely did. In fact, that was how you had these different companies making a name for themselves, because they would implement the hardware that carried out these actions in the best ways, or were specialized um, circuits to carry out these complex networking actions in certain ways. Yes, they had software running on them, but they were basically selling those big metal chassis to service providers and enterprise customers that needed um, all of the bandwidth and ability to communicate. So not anymore though, because a lot of things have become virtualized. So software is being written in ways where it can be deployed anywhere. It can be deployed in a cloud, on in any type of container-based deployment scenario. So the hardware is really moved out of the picture, and it's now companies like Dell that just they build servers that are universally available for almost any application. Or you have companies that just provide, like Amazon. You can run whatever you want to run in their services, and you can identify how you need it to scale, and they just allocate you more processors, more networking ports, whatever it is that your application needs are. The software is now more like the focus, I think, than it is actually the hardware. There are a few exceptions to that, and I would just say that that might always be the case as you see brand new technologies trying to be implemented. For like an example, and I don't know much about this space, but artificial intelligence is a space where you have companies like NVIDIA that specialize in developing chipsets that will carry out these really complicated artificial intelligence based algorithms that run very, very quickly. Software needs to be developed in ways to utilize that hardware, but that aspect of that technology is something that is built into that hardware.
And how did you get into Cisco?
Cisco, I got into basically, again, I was like on that 18-month sort of, I need to see something different. I need to see something different. So I was at 3Com for about 18 months, and then I moved into a different group at 3Com, and then I was there for that 18 months. And I don't know, it was not something I was really measuring until I looked back on it, but that was just sort of my, I don't know, my own biological clock saying, hey, I feel like this is a good time.
Need for change.
Need for change, need for exposure and something different. And I started at Cisco in a group that did MPLS, which was a sort of in between layer 2, layer 3 forwarding technology. Which again, at that time I was working a lot with how packets got routed between networking components in the internet. So I was understanding how these routing protocols worked and writing code to implement certain functionalities of those routing protocols. And now this was like, hey, this is the new best thing, this MPLS. So that like, oh, new best thing? Oh, that's shiny. That's new. What's there? So I went to that and started doing development into traffic engineering, which was basically a problem that network providers were trying to solve, where if I have customers here that are trying to use the internet, and I have all these resources that are around the world that can route those packets and all these different pathways to get from here to there, how can I best optimize my network to serve all of these different customers so that I'm gaining the most benefit of what I've deployed out there? to just have like sort of physical cables that aren't carrying as much bandwidth as they're capable of is inefficient. But you need redundancy, right? If you got some utility work that's going on and it cuts into a fiber main or whatever, you don't want people down for days until that gets fixed. You want other routes that you can travel. Um, that does break down in the network, in the like neighborhood, obviously. But if you think of it just in terms of more uh, larger scale, if a data center goes down, you don't want everyone to be impacted. You have to have redundancy built in. So traffic engineering is trying to help out service providers better utilize their network and provide quality of service to their customers. So I spent a lot of time at Cisco working in those different features and functions that we're supporting for traffic engineering.
What was the day like?
Throughout my whole software career, I think it's basically trying to understand what it is that we are wanting to do, breaking down a problem that just seems kind of big into smaller pieces, but at the same time trying to keep track of how those pieces go together. So a day for me would be, organizing my own tasks of what do I feel like I need to do. Some of that might be a little bit of future planning, like, okay, what is on my plate? What are some of the things that I'm going to need to think about? Because it's not just writing code. It's a lot of just analyzing information and problem solving. A lot of it is fixing bugs. I mean, that's actually one of the best ways of learning when you first start with something. Like, hey, I'm new. I don't know how any of your software works. And they'll be like, oh, great, because we have a lot of bugs. You can figure out how it doesn't work to figure out how it should work. So that's starting with that problem solving skills. It's like, okay, well, you don't know what you don't know. But what do we know? Are there things that we need to learn more of? How do we get that information? Sometimes it's writing code that you can gain more information from. You're not fixing the problem, but you're getting more information about the problem in order to try to understand what that root cause issue is and solve it. So on any given day, you might have problems, bugs. Those might be priority based, and that consumes your day. You might have things that you're developing, features that need to be complete by some sort of target date. So those are more a little, somewhat longer term. You need to try to balance that. Throughout the day, you're going to meet with your coworkers, in your management, and you're going to have a sync up to see where are we at with things, what obstacles are people facing, are they blocked, what needs to be done to get people unblocked. You're going to have collaboration with your peers. Like I constantly on Teams. We have so many different team chats, and of course there's many different chat forums that can be used for this purpose. But at our company I'm currently at, we use Teams. So many different groups where you have the interested people in those groups that are aware what type of problem it is you're working on, where we just communicate back and forth. Hey, I saw you ran into that problem. What debug did you get back? Let me look at the log. Let's see if we can figure it out. Ask another coworker, hey, this is what I think might be going on. Does that make sense? And like maybe we should look at this. So there's a lot of back and forth that goes on throughout the entire day of just trying to break down problems, solve them, if it's issues like that.
There is a term actually for this. It's called functional decomposition.
Yes.
Breaking down complex tasks into simpler ones. Speaking of which, would you say that debugging is 70 to 80% of the job of
Oh yeah.
software engineer?
I might say even more. Yeah, because no matter how much you try to implement flawless, perfect code, you should assume you're going to have a bug. You should assume that. One development strategy is to do test-driven development. And by doing that, what it means is you're basically working with some programming language where side by side you can write a test program that's going to run those codes. So you're like, I just need a function that's going to tell me what this particular configuration is so that I can use it in this way. That's broken down really, really finely. But, that configuration file that you're reading from, you don't know that it's going to be perfect. So you might develop a test that says, here's a config file that has what I'm expecting. Does it work? Great. Here's a config file that has not what I'm expecting and is wrong, or has some other variables assigned to it and things that I don't care about. But is it still working? You might find that you wrote code that made assumptions or didn't consider things that you needed to consider. So you run those tests and you find your bugs and you fix them, and you go in that iterative way of finding and fixing issues. So
For me, debugging is like walking in a dark forest looking for an exit.
yeah, and there's different tools that are helpful depending on the situation. Um, uh, this is, again, most of the programming I have worked with in my life has been C, C++, and most recently Go. And it is still funny how this comment is true, which is with embedded systems, when you're running code um, to do whatever function it is you're expecting to do, and it's not working. One of the best debug tools is your printf. It seriously is. It's just, here, I need to dump out everything that's going on in this particular situation. There's definitely other tools like GDB that you can use that can execute your program step by step and allows you to see each register as it's being set in the program and what things are being placed in memory and all. And those are tools that you definitely do need to use in certain situations, but the majority of problems are just simple mistakes that you just, as you're programming, you're writing your code and you're doing it in a way that you feel like, oh, this is going to work. And nope.
I did not want to sound old school, but I do use print statements mostly for debugging.
Yeah.
Rarely I use the debugging tool in some cases when I see what is exactly allocated to memory and not shown in the flow. But yeah, print statements is my best friend.
Yep.
Would you say that still lives up to date?
I do. I mean, there's definitely certain problems. Like once you get past, those are the glaring bugs, the ones that are kind of easy to fix. Once you get into things such as scale, resource limitations, timing, concurrencies, memory corruption, those are problems that are more difficult to solve with just using printfs, because what's happening is you have software running at different times, someone simultaneously trying to grab resources, and even within those contexts, things are changing that weren't designed to be changed. And in order to solve those type of problems, you need more information as to what is going on within that particular process or that thread of completion. What is the current state? And even then, sometimes debugging it can prevent the problem from being seen, because you are step by step executing something and it's not running at real time. So there are tools available to software developers to help debug and analyze those complex problems. Also, another thing is just performance. You might have a bugless, software package, does everything you wanted it to do, meets the requirements, but then a new requirement comes and now it needs to do a little bit more, or run under more or fewer resources, or run with more users, and the system starts to not work as well, and you want to improve the performance. Maybe it's just delay. Like my user, they send this request, they expect a response. But when I have a million users, it still does it for most of them, but not all. Some of them time out. Why is that? Can you make it better? So then you have to break down your software and analyze it with tools that can help you see where are some of those bottlenecks occurring, and where am I spending most of my time processing. Are there other ways I can break apart my software to make it more efficient and be able to accommodate more users and higher throughput?
So there is no one best solution
Mm.
when it comes to writing code. There is a platform called LeetCode, and they post challenges and questions, interview questions on software engineering. And just the simplest ones, like reversing a list, you can come up with dozens of solutions actually how to do it.
Right.
But there is no single right answer for it. And there is a big difference in complexity,
Right.
which is also, I think, an issue in in the job that you describe. I don't know how you handle it on such a big scale at a company.
It depends, really on what are your deliverables. You know, if you establish requirements and they're solid, and you can go into your development knowing that these are the requirements that we need to meet, you're in a better situation of being able to write code that will at least adhere to meeting those requirements. Um, the problem can occur when whatever your design is then we try to use it in meet different requirements or meet expanded requirements, and you realize I implemented this module, um, in a way that doesn't scale that well, meaning maybe the communication between these two processes is just sort of synchronous, where this guy is sending a request and just sitting there kind of waiting while this guy processes it, and this guy isn't able to do much at all while it's waiting, which then means that anything that's relying on that is also waiting. So if you add the complexity in ahead of time, you're sometimes better off, but adding that complexity costs time. So it really is a balance of what do we need to meet, when do we need to meet it by, and can we afford to come back and improve this sometime later? Um, a lot of times engineers, we don't have the answers to those questions. That's for other people that work with customers and marketing. And they do that job of like, selling the best that we can do. And then when it's needing to be given more time, they do that job of like, hey, well, this is what we've got going on here, but we can do this for the next release. That's their job. Ours is to deal with what we have been told are sort of the requirements. But they're definitely, as you go and in this career, you see some of the same pitfalls that you've experienced yourself. It just ingrains in your brain. And that's one thing I think you'll find with more senior software developers is we can write, if you gave the same problem to someone who is, let's say, new versus 10 plus years of experience, and let's say it was a more, let's say it was a problem that should be easily solved by both. My guess is it would be much harder for that senior developer to write this, to solve that problem at the same speed as the newer person, mainly because of all of the reprogramming they would have to do within themselves to not think of all of the possible error conditions that are going to come up, because the problem has been simplified in such a way that it's not real. So you're going to embed it in your brain as to, oh, well, what if the input isn't this? What if that's not the case? What if, this now needs to be called by these other things concurrently? So there are these aspects to it that just automatically churn in your brain because you've seen these problems happen over and over and over again, and you hate going back to rewrite code or like change things that have already been done. Um,
There is a joke to it, like when you see um, someone else's old code, just don't touch it. If it works,
yeah,
don't touch it.
if it works, don't touch it. Yeah, that's somewhat somewhat a good rule. If it still works the way that we want it to, yeah.
And what about reading others people's code? I mean, by now you probably have an eagle eye for this and you're comfortable, I would assume. But when you're just beginning, I know that reading others people's code is not that easy. Could you give any advice on this one?
I'll start with my own self. Sometimes my goal is to be able to read my own code 2 years from now and understand it. Because I'll be honest, I've done just that, and I've looked at a bug, and I'm like, "Who wrote this?" And just to find out that, oh, that was me, because you're going through so many different issues and problems and features and functions, and there's just so much going on. If something's not broke, don't try to fix it, because you can definitely break it. There's always a concern when you look at code that has existed for so long, and now you're wanting to do something different with it. Um, and it's a bit scary with messing with some of those type of things because you don't know how that was, what assumptions were being made at the time, but you know that, hey, this has been deployed, it's been working, it's been solid. I know you need to now make it do something different. So there's different approaches that some people take with how to deal with that, but it is one of the scarier type of situations when you're dealing with old code.
What were the biggest challenges for you at Cisco?
Oh, well, there was, I think, several big challenges at Cisco. One of the things I worked on was high availability. And what that means is that if you have a networking router that is carrying traffic, but it should experience some sort of failure with the software it reboots, you want to be able to switch over to another router that's going to be allowing that data to pass through. But it's not just that the data is passing through. All of the state that was associated with that system also needs to be carried over. Back when we were developing this, there were not the same type of models to solve this problem. A lot of there's been much development since then, but when you're working with a chassis that has its own memory systems and resources, it's self-contained. It's not out there on the cloud or available from some other system. So it needs to communicate with its peer system in a certain way that isn't going to impact the traffic. So the complicated problem there was trying to maintain and determine what is the minimal set of state that is associated with this data traffic and all these users that would need to be sent over to a peer, so that if it had to take over as you had this active standby model, if it had to take over as active, what's that minimal set of information it would need to basically rebuild everything in a way that it would have occurred on that other system when it first happened. So there's just a lot of complexity there with minimizing the data set, what information has to be synced over at live time, what information can we just sort of learn from other information that's already there and rebuild it, and just minimize that time that it would take for it to become functional to support new traffic and new users. So that was a lot of time spent in that area of high availability and redundant systems.
Did you use Scrum?
We at that, I'm trying to think. It's Cisco, because I've been at Cisco a couple of times actually. The first time I was there, we were not employing Agile Scrum. Back then, we were doing what was called a waterfall model of development, which was more people would consider more slow to implement functionality, but basically meant like, okay, you have these different stages of your development. You know, you're gathering your requirements, and then sort of designing to those requirements and architecting your system, writing functional specs as to describe how it is you're going to design things. Okay, now you're going to implement certain parts of that code. Now you're going to, test. And so you had this natural progression of you can't go to this next step until you've done all of these, and then you release it and test it. So um, that was the model we were following while I was at Cisco the first time. And then went to a different company where they were using Agile Scrum because they wanted to break down things and be able to provide features and functions much quicker than a long, like 6 month release schedule. They wanted to be able to put out new versions of code for their users to just update at a much faster pace. And Agile Scrum is just a methodology of people being able to develop where they can say, here's a whole list of things that we want to get done. Let's take stuff and break it down. It's hierarchical. So you might have, we want to be able to release this protocol and support for it. And then now you break it down like, okay, we want to be able to do this call flow where user A is able to send this request and it is processed and returns back this. So you break those things down. You may not be able to say you fully support that function until all these things are done, but you can design and develop your code and test it where that one piece can be completed, it can be tested, it can be now part of what you are able to offer to your customer. So it's just a way of breaking things down into like 1 week, 2 week type of periods where the team looks at these are the things we can feel like we can get done and actually be able to provide to customers within that time period, which includes the design, development, any documentation and test support and all that.
For those who don't know, Agile is a project management and product development approach that prioritizes flexibility, collaboration, and customer feedback. If we look at the stages, it is broken down into planning, design, development, testing, deployment, and review. You mentioned that you break down your tasks. Smaller pieces always build up into something bigger, and you work in teams and you work in sprints, if that is the correct word for it. It's the 2 week standard.
Right. 1 or 2 weeks, and I think it like at Casa where I work now, it's not a policy that all of our teams follow. It's a hybrid. I mean, so when you use the term Agile Scrum, you're being pretty specific as to how your development process should run, and you're also like assigning certain members of your team to have certain roles to follow through that particular methodology. Such as you have a scrum master who is basically like the coach who tries to get the team together to discuss what are the things we're trying to accomplish, how long do we think that they're going to take, what's the cost, what information do we still need in order to know what needs to be done, what is the definition of done for this particular thing. So you have that person who is like a scrum master that's coaching. You have all of the individual contributors trying to be working to those tasks. And you have someone who's responsible for like the ownership of the product and saying, these are the things we need to prioritize. And you mentioned how it's, adapting. It's flexible and it needs to adapt. That is one of the main benefits is by keeping things on a 1 week, 2 week, you can be iterative. You can say, this is what we're able to do in this time period, and we can present it to them, they may have feedback. That other model, the waterfall model, you kind of gathered up all of your requirements, from that customer ahead of time and had discussions on them. And then you go out and you go start implementing, but that feedback to the customer is kind of long further a ways out. So if you can get that feedback faster, it usually will result in you being able to make software that works better and meets the needs of the customer sooner, instead of getting somewhat blindsided by, oh, you needed it to run in that environment under those conditions. Oh, well, that's another 6 months.
Yeah, it takes time to scrap all the feedback and to go through it. Do you have special employees assigned for that kind of job, or is it interrogated into
To gather the feedback,
and work on it?
it depends. So you definitely, in most companies, will have engineers whose job is to interface directly with the customer and understand what their environment is that they're going to be deploying your software or whatever you're developing, and just stay in contact with the customer and the development team to make sure that those expectations are understood. And if there's any challenges being met by the development team, to try to work with the customer of identifying, is that really a requirement, or is that a wish list item, or is there maybe some other possible deployment or solution that you haven't considered that we could use along with our solution to meet your needs. So that's kind of their job, to try to be our in-between.
It's like a dance to it.
It is a very big dance. And as an engineer, most of the time you're insulated from a lot of that conversation. We do provide demonstrations of our software to our customers. And in fact, one of the things I'm recently working on right now is in preparing for a demonstration of some software to a customer. And the last 2 weeks have really been just brutal of making sure that our software is running in this environment that we know the customer will be deploying it in. And what are the challenges that we face with that, and things that we hadn't seen as we maybe have done our testing. So those are, again, to not only demonstrate it, but to get feedback from the customer.
Yeah, it seems that like in many companies, there is a big distance between the actual engineer who writes code somewhere in the company or even at home, and the client that uses it when he presses something and it doesn't work.
Yes, usually. There has been one case in my career where that was not the case. And I was basically flown down to New Jersey to a UPS facility to fix a problem as an engineer.
That is customer service.
It felt like Star Trek when, Georgie had to go to engineering because the work cores were down. But in this case, it was just the big brown. They weren't, their routers and network and switches were just down and broken. It was a complicated problem that at that time, I was working at 3Com and developing a much old switching technology called token ring. So there were all these different technologies coming out to try to increase bandwidth for customers. And we had this switch that basically ran in their enterprise network to carry their traffic to all the different locations it needed to go to throughout that building and other buildings. And then it interconnected over a technology called ATM, which is now way outdated. No one talks about asynchronous transfer mode anymore over fiber. But anyway, at the time, they had a card that you could put in the back of this switch. So you went from token ring, another outdated, crazy technology, to ATM, another outdated technology. But what they kept seeing was after a few months, all the traffic, every bit of it, would stop flowing through their switch. They didn't know why. We tried debugging it with what we had. We weren't able to determine why it wasn't forwarding traffic, the only solution that they could have was to reboot the switch. Reboot the switch, everything would work. Again, for another couple months. And then it would stop working. After a few times of this going on, one of our QA engineers is like, well, this is happening every couple of months. We can't find it here in testing. He went out and rented from, I don't remember, was it PC Connection or somewhere? He rented like hundreds of PCs to try to simulate the users of their system just generating traffic, because we felt like it must have something to do with over time the traffic load, or I don't know. So I'm looking at our system one day and I observe the moment that the traffic stopped. And I'm observing it using a packet capture device. So I'm capturing all this thousands of traffic. And I see the moment where it stopped forwarding. So now we have a snapshot. But on any kind of packet capture device or software, you basically have an entry for every single message that's sent. So now you have this big haystack, and now you need to find that needle. And I had a theory, which was that something was happening to cross a boundary within some piece of the protocol's implementation. So if you break down a message protocol and look at what the contents are, the way they're defined is each bit has a specific meaning, and you can combine those bits into bytes and multiple bytes, and each might carry a particular piece of information within the network. And you think of it almost like an envelope within an envelope. I write a message to you, write it on a note. I'm writing it in a way that you could just read it when you get it. But what do? I take that and I put it in an envelope, seal it up, and now I have to address it to whoever it is going to deliver it to you. So this is like how networking works. There's different layers. So I have to address it in a specific way that whoever's picking that up to deliver it is going to understand how to deliver it. They might have multiple ways. I might have to make sure that I include a care of. I might need to make sure that I've put all 4 digits of that zip code that's useless on there to make it sure that it gets delivered to you. And then they might take it and put it in another envelope or a bag that is other protocols associated with, all the things in this bag get taken over to that side. So you can think of it in that way. And what I was observing or thinking is that there was something being addressed at some point that broke that system. And when I looked at the packet, one right before that did get delivered and one right after that did not, I observed a difference where there was this, I want to say 16-byte address. So with source routing in token ring, you could run it in multiple ways with the token ring switch. You could run it in source routing or not source routing. And if you ran it in source routing, how you define that address was slightly different. And what we saw was with that packet that didn't work, the next most significant bit was always set. As soon as that bit got set, traffic stopped working. And I looked at this and I like, this is a hardware problem. And I went to our hardware engineer who wrote ASICs at that time, specifically designed to help move packets along more efficiently and look at the bytes and bits at those layers without having to pass it up to software. And I asked him, can you run a simulation where this bit is set? And he's like, well, we've tested this all out. It's fine, and all the tests work. I know, but can you just do this for me? He ran it, and his face, the jaw dropped. He's like, it's not working. I'm like, okay. And this was a moment where I'm like, all right, we now know the problem. It's this. How do we fix it? That's now a hardware problem, and we've already shipped all of these devices. We can't replace them. That's way too much money.
Wow.
What we ended up doing was, in software, we limited the range of, so all there was a sequence number. Every packet that got sent out obtained a sequence number. The next one, the next one, the next one. Once it got to a certain number, certain most significant bit got set. The hardware was always looking at that bit to say, is this being source routed? It's source routed now, and it did the wrong thing. So I said, as long as we don't set that bit, we should be fine. So I wrote the code to just limit the range of these sequence numbers that we could issue out. So it would roll over much shorter than what it was designed to do, but it prevented you from running into that hardware problem. So they flew me out to New Jersey so they could be there to roll out this new software. And I had to stay there for like multiple days while they verified the fact that, yes, we've seen it roll over now, and verified that the fix is working.
And when was that?
That was I'm going to say 96, 7, somewhere around there.
It would not be possible to run into problems like this now.
You would think.
Yeah.
But it is. It very much is. I mean, if you think of, just the systems that are out in all parts of the network, there's a lot of systems that are old. Yes, things are being moved off of hardware and into cloud and into, servers that are much newer and replacing this monolith type of chassis environment. There's still a lot of this hardware that's out there. And yeah, you can observe these type of issues still today where you hit a boundary, you hit a limit where some threshold gets crossed, there was a bug, whether it's hardware or whether it's software, and it starts behaving in a way it's not supposed to.
This is an amazing example, actually. One little thing at the bottom of a pyramid could potentially lead to a crack up to the top.
Yeah, pretty much.
Yeah, you also have to you have to be cautious to look for these things. Have you ever faced imposter syndrome doing your job? Or other people around you?
I'd say yes. That's a deep question. All right, so I mean, I have observed imposter syndrome from others, and it's usually people that are just probably not clear on whether they want to be where they are, and that isn't to say that they don't identify as wanting to be a software engineer, but it might be that they don't feel like they fit well where they are at in the group where they're at.
Team-wise.
For myself, I think there's been one place where I did experience that, in the sense that I felt I was surrounded by a group of people who were very knowledgeable on a specific technology that I had no knowledge about, and I was just coming in to learning about, and was trying to find, where can I add value, and I wasn't feeling I was being given opportunities to provide that value. I felt as though everyone else like, that's my space, or that's my space, that's my space. So I don't know if that's so much imposter syndrome as it is just not feeling like you're really a part of the team. But when I think of imposter syndrome, I think it more in terms of someone who feels like, this is what I want to be. I'm going to present myself in this way. Whether I'm really that confident about it or not, I'm going to do it and present myself so this is me. So that others will feel I'm equal.
That I'm needed.
And I'm needed, right. So... yes, I have seen that in other people, and I think what happens in those particular cases was that they had their own realization of at least where they were wasn't where they wanted to be and wasn't where they were comfortable being, In other cases, they also definitely said, you know what, I made a wrong decision with this particular career path and area. I'm going to pursue something different.
Here's the assumption. You know what you know, and you have other people working around you on a task. Imposter syndrome, in the terms of you being new to the team, thinking that you probably don't deserve being here because all these people around you are saying all these smart things
Mm.
and you don't have anything to propose just off the top of the head. And assuming that, oh, these guys, they know other frameworks, they know other languages. And that could lead to doubt, and that could lead to the imposter syndrome.
Okay.
I'm asking because when people now enter the field, it is so rapidly evolving, and there is like this unspoken of competition that you have to know at least 2 languages to be offered the job, to programming languages. You have to do at least all the easy assignments on, be able to solve all the easy tests on interviewing questions on LeetCode or other platforms. There are so many things that you have to know and do. And when you get into the environment, into the field, into the job, a lot of people feel misplaced and like they don't deserve it being there because the salary is usually more than an average salary of a software engineer. And it's not a particular job where you take something with your hands and it's tangible. It's often wise somewhere, and it may be even that small thing that you've been working on for a long time, and the planet is still spinning, nothing changed, but you still get paid. And that's where the imposter syndrome comes in. And I read that a lot of people were facing that issue, and actually a lot of people got burned out on that. Do you have any policies or, I would say, strategies in your company now to work on this?
I think what you're speaking of is basically someone understanding that they're valued, and also understanding, where they are in terms of their own career maturity and understanding and learning and skills and expectations. So, I've worked with great people who are, I want to say this is the majority, and I'll say it is the majority of most of the people that I work with, being like-minded, have this real desire to want to see other people succeed, see other people contribute, and feel good about that, and learn from it in almost like a mentor way. I've been a mentor for multiple people throughout my career. It's something I really enjoyed doing, because I just feel like you can't assume that someone's going to be able to do. I can't do everything I'm expected to do on any given day. That's just the way it is. We're human. Some days you're just not going to be functioning at the same level that you know you're capable of. But then again, you don't know what you don't know. You have to learn it. So you have to be trusted to be given those opportunities, but you also have to be given it in such a way where you're not just left out to dry or set up for failure, right? You need to be given resources that you can go to and feel comfortable going to, who can help you along that path, work with you. One of the most enjoyable times, I think, at my current position with CASA was we had 2 engineers, young, that came in, right, pretty much from college, that they weren't familiar with wireless technology. Heck, I wasn't familiar with wireless technology when I first started there. Um, so in a way, it was good for me to be able to convey that and say, look, this is how I came in. And yeah, I've been doing software development for a long time in telecommunications, and as far as the technology is concerned, it was new to me. A lot of this new to me. But one of the things that we need to do is really be able to test some of this code that we know we haven't really shaken out, and we want to create a framework to be able to do that. And that's more of a general problem, and we can shape that. We don't necessarily need to know much about how the technology itself works. We just need to know about how to structure a framework that can exercise these functions in different ways, and make it flexible enough for us to see all these results and test it and find out where problems might be. So, we met, and it was like doing it with just the two of them and the three of us. That was our little team. And it exposed them to the code. It exposed them to the tools that we use for development, exposed them to how to deploy and run the system. It was a good exercise to like introduce someone into something. And it was being done where it was both of them together. And there wasn't just single pressure on one person. So yes, I do think that there's things that can be done to help young engineers come into an environment where they're working, be given certain tasks to do, feel like they're making progress and learning things, feel like there's it's safe for them to make mistakes. Being able to be transparent about that, like just hey, this is what happened. I didn't notice it. I should have seen this before. This is what I could have done to prevent it. Let's try to remember that next time. Being transparent like that, I think helps maybe other people to recognize that, okay, yeah, it can happen. Things can fall through the cracks. Mistakes can be made, and we can move forward. It's not the end of the world.
Yeah, a lot of starting software engineers could be a bit overwhelmed by that, because before running into a company, all you get to do is do these tests, simulations, solving puzzles, reversing these lists or whatever. And the question that you get in your head mostly is, how is this possibly related to a future job?
Right.
Am I going to be reversing lists on the job, or what's the point? That's why a lot of people get a bit overwhelmed when they go into their first position now. And I'm just saying I would assume it is a bit different now than it was before. And the competition, I would assume, to become a software engineer now is much more than
I would agree. I mean, when I was going at the beginning of my career, there was such a need for software engineers. And I fully admit, I was just lucky to be in that time window where literally people would be hired without having a degree in programming, because that was the need. And here's the fun, interesting fact. People who didn't have any background in computer science, who took jobs, became very successful software developers because they had certain attributes that were just inherent, that like the problem solving skills, the ability to communicate well, the ability to break things down and organize things in ways that are somewhat methodical, and to look at some things in a big picture as to how all these pieces can influence one another. So there were just all these things that are outside of being able to reverse a list that are important for someone to recognize as important and valuable. And in a lot of ways, this is, challenging to teach someone how to do. I mean, you can show someone how you might do your work and how you might think, but my thought is that a lot of that comes from that person as they develop themselves and how they go throughout their life, determining what works for them, how they break things down in their own head, and how they do learn from other people. So, it's a good thing to do to observe how other people work and what you feel is, hey, that person had success at that. I might be able to learn from that. Maybe I can ask that person or just, see exactly what it is that they're doing and consider that and how I can apply it. Um, so those are the things I feel are really important, more so than, what college that you graduated from and what degree that you held. Is just that ability, need for your own learning and development and fostering it, and continuing to to put yourself into those challenging experiences and learn from them.
I would also like to add to that, apart from being able to solve problems and willing to learn code, there is one other trait I think that is very important, is being able to look and acknowledge your failures. For example, the lesson that I learned when I started learning to code is that if your code doesn't work, chances are that the problem is in your code writing skills. 99%, not the hardware, not the whatever issue might be on technical wise. The biggest probability that your code does not work is because you just wrote bad code. And that was a truth that was hard to get by, because when you come from a non-coding world into the world of coding and you write down the algorithm for a simple program to-do app or whatever, and it doesn't work, and you start blaming everything around you, but not the code itself. It changes your mindset, the way how you think. You have to acknowledge that you are not perfect. And problem-wise, you are the source of the most problems in your code. That was particularly hard for me to understand, that if something does not work, then I've done a bad job.
We are inherently like our software, and we are buggy.
Yeah.
So,
But I'm just saying that because it was a very high contrast for me. If you come from a world of non-coding into coding, it changes your mindset, the way you think, the way you approach problems, how you start to decompose everything and approach challenges, whatever. As an unprepared person, if you come into this, a big thing might be is to understand that if something doesn't work, then it's probably you did a bad job. It may be a difficulty for a lot of people, newcomers, I mean, into the field. And there was a trend. Back in the days, you would need to get a degree, as you've said, to be a software engineer mostly, even though there were people who were without a degree and still succeeded, but the numbers were less than now. Particularly speaking from COVID, I would assume times have changed, and all these boot camps started promoting these quick educational programs, learn how to code in 4, 6 to whatever months, and become a full-time developer, back-end, front-end, for just a small price. That kind of changed things, I would assume. I don't know how it ended up employee-wise. Did that impact the quality of employees? We'll get to that in a moment. My point is that all these boot camps, they started to produce these fast-made self-called software engineers, which probably might not be the case for all of them. You've probably encountered those people, and my question is, when you do interviews for your team that you form as a principal software engineer, is a boot camp a red flag for you?
I don't know if it would be a red flag, because I mean, I would think that if that were the only thing, then
No degree, just a boot camp.
yes. I mean, it would. If that were the only thing, I mean, it. I think that there would need to be some prior demonstration of experience or interest,
Portfolio.
something that says, you know what, this is um, something that I've been wanting to do. I feel that this is something that I can be good at. These are things that I have done along the way to try to reach this level, that I could have a job in this field. And just a boot camp, I don't think represents that. Um, and I understand that the college and universities are a huge cost, a huge, let's say, investment. But I just feel like there's other avenues that someone can take, especially because of all the resources that are online. If you are really driven to become a software engineer, what you could be able to say is like, hey, I don't have the formal background. I don't have a college degree, but I am very involved in these communities online. I'm very involved with um, writing this, writing code in this language because I wanted to learn how to do it. I've solved these particular problems. I've worked and collaborated with these people online. We had this idea that we wanted to be able to make this thing, and maybe this thing is kind of dumb, but we thought it was the coolest thing ever at the time. And we started developing it, and it fell apart and fell to crap. But this are the things we learned along the way. You know, that level of interest, that level of excitement, that level of being able to go out on your own and find opportunities, aside from just, I took a boot camp, I learned, you know, C++. I can write a code that displays my name over and over and over and over again, and yay, object oriented. So,
What what would you say are the most important things in a candidate now for you as a principal software engineer? If you're interviewing a junior developer,
I mean,
if
their
there is such a thing.
willingness, I'd say their willingness to learn, their willingness to um, accept challenges and, do it in ways that, I shouldn't say do it in ways, but um, being driven to sort of drive their own path, meaning they do seek out help. Now, granted, I understand your environment and the resources that are there will help support that or not, but they need to be able to be willing to put themselves out there, to ask for help, ask questions, because what happens is, and I do feel this is true. I do feel like most seasoned software engineers do want to help, but and I also feel from my perspective, and this is probably a lot of us are very uh, able to be distracted. We work on this and like, oh, that, and we juggle a lot of different things. We also sometimes have the ability to really hyper focus on something, but just because of the nature of what we do and all of the different issues that we're dealing with and timelines and deadlines, we are juggling a lot of balls at the same time. We want to help, but if you don't come to us for help, we don't personally will allocate the time to go out and seek you to say, hey, how is it going? Do you need help? Are you stuck with something? That actually is a purpose, though, built into a daily sync-up meeting, is here's an opportunity presented to the team for anyone to just, hey, I'm stuck. Don't be afraid to say that you're stuck. And, do ask yourself if you say you're stuck multiple times, or if you're just not saying it but you know it. Be able to admit that you're just too scared to ask for help, but you have to. That's one thing you have to do.
Yeah, it's tough. You have to overstep your fear because you especially if you're starting out, you don't want your colleagues to think, oh, come on, that guy, he's asking so many questions.
I mean, most of us remember when we were that age, so it's not, something that we have that expectation from.
But still, what you said applies to people who are already in the team. What about those in the interview? You said that you're looking for willingness to learn. How can you see that from
an interview?
From an interview. It's barely a conversation.
It is, it's difficult to see it. I think that does sort of present itself from, like I said, what are your experiences? Tell me things that you have done which represent a willingness to learn.
Okay, but what if you are hiring? Do you hire, by the way, starting out, like for people who just graduated?
Yes, definitely.
Even now?
Yeah, we've actually brought someone on. They started 2-3 weeks ago, right from college.
And what were the requirements for that person, for that position?
I will not be able to say specifically because I wasn't involved in
Just
that
overall
interview process. Yeah. But my assumption is that they had a BS degree in computer science or equivalent.
What does that mean?
Typically, I mean, it means you might have had a major in let's say electrical and computer engineering or something like that, but you have computer science knowledge. You have you have experience with software development.
Okay.
And probably some minimum level of GPA from that school.
So those without degree don't even stand a chance.
In that environment?
Yeah. What about a master's degree?
As far as a requirement versus like a person coming in an interview?
Yeah.
Personally, I look at it as not necessarily a higher candidate than another candidate. And I only say that because that person getting a master's degree could have been multiple reasons why they chose to do that, because it might have fit their situation better. The person with a bachelor's degree might be just as equally competent in terms of computer science and ability to program, but their situation is different and not opening up a opportunity to pursue a master's. So it's just something I think you have to just keep in mind when you're interviewing someone, and not be so quantitative as to what is listed.
Do you explain to HR who you're actually looking for?
So typically HR is pretty good at knowing what the company needs, and it's based upon management's direction. What are projects that we're trying to invest in heavily? Where do we have commitments from customers? So which groups have the most need, right? And so HR, that is actually one of their jobs, is to try to come up with where can we find good candidates to meet this group's needs. Now, that also might open up some different aspects. You might have a job opening, let's say for a more entry-level position, right? And you go searching for a candidate. You have people that apply that might be, all different ranges. They may not be entry. They may be, they may have been working in the field for a while. They may have been working in the field for a while and then took a break for whatever reason and are coming back. So those are all in your pool and they're coming to you for interviews, and it's really the team trying to get a feel from that person about how well they would integrate with the team, and that's a factor that's outside of that candidate's realm. It could be that they are super great at doing certain tasks, but you know what, we just don't have that need. Maybe they like their abilities to create front end web interfaces and user interfaces is phenomenal. The work that they've done and programming that they've done in that space is great. But you know what? We really need this, and you have no experience with deploying in Kubernetes or clustered environments and debugging in that type of environment, or you don't have any skills or experience with protocols that are used in telecommunications. You have not done any embedded programming. Those are aspects that are specific to our needs. So it's just that particular candidate might not be a good fit. Now, if and I think this is the case, if HR is doing a good job, then they will have somewhat weeded out, or not wanting to waste an interviewer's time, because they'll know what the needs of the team are, and they'll say, unfortunately, the things that you have experience with, they just don't align well. Does that mean that you shouldn't be given the opportunity? That's a good question. And in a world where there were no deadlines, in a world where there was no capital at stake, yeah, sure, but it's not the world we live in. But hopefully there's other places where those skills that person have will align well, and they'll be a good fit for.
How do you form a team?
Whew, well, I mean, it's always ad hoc, honestly, because you're. I've never been in a situation where it's like, okay, go form a team to do this. Hire whoever you want. I've never been in that situation. And I think you have to be a startup company to do that. I've never worked for a startup company. So forming a team is something that happens over time. And it's all about building up your connections as you go through your career, and just kind of keeping in touch a bit with those people. As you work with people that you find really click, remember them. Remember what it is you did and worked on with them, why you felt that person worked well at doing what they did, why they worked well with you. Because a person doesn't have to be just like you for you to work well. And in fact, it's sometimes very much the case where complementary things are really good at being effective, right? That does come with a bit of a price. You might say, I did this, I wrote this code, check it out, it works. And that person's like, dude, no. You can't do this. You can't do this. You can't do that. You have to be able to take that input, especially if they're right. And you're like, oh, wow, I'm glad that I had this person who could be that honest with me to tell me about these things. And that works well if it works well for you. But make note of those type of people throughout your career and just build up those relationships and connections so that as you move throughout your career, when there are opportunities that present themselves and that person is there, you can say, hey, what are you working on? I'm interested in maybe working along with you again and doing what is it your team is building. It just opens up those type of doors for, like you were saying, how do you build a team? That's your own way of being able to form that. And what I have seen over time is people do that, because throughout their career, you work at big companies, layoffs happen. It's just part of the system. Restructurings occur. People have a job, might last for 1 year, 2 years, 10 years, at some point, things happen where they are let go, or they decide, I'm not happy here anymore. Things have changed. They want to look elsewhere. So that's when they go out and reach out for those connections. Other people have done the same thing, and you find, oh, so-and-so, they went there too. Oh, now so-and-so is going there because they're working on something really interesting. And hey, I know all these people. I'm going to look into that now. That's how they form a team over time and just making those connections.
To close the topic on interviewing, if you have a candidate who got through HR to talk to you, and what would your pick be if you had two people in front of you? One is highly skilled in one particular area and somewhat skilled in others. And two, the second person is evenly skilled somewhat in multiple areas. For example, he knows Python, Java, he knows how to manage and create relational databases very well. And that person only knows relational databases, but he knows that topic very well. And let's assume you look for a guy who knows how to work with database. Both of the candidates are good. One is more specialized than the other one, but the other one is more broad in knowledge. Hypothetically speaking, what would your pick be between the two?
I think I would ask the person who specialized in the databases, hey, is that your passion? Are you really into databases and like that's all you want to do? And if that person were to say, yeah, I love databases, put me in a job where I'm just doing databases, I'll be happy. Honest opinion is I would think we would not be able to promise that person that that's all they're going to be able to do. That's just kind of the world we live in. We need to be able to adapt a bit. That's if it were me making the decision, but I'm not a hiring manager. So
Sure.
If there were a hiring manager who said, oh my God, we have this project that we have to get out, and the only way that we're going to be able to get it out in the next 6 months is to hire somebody who knows all about relational databases and can program that crap in 6 months. What they do after that, I don't care. They might be looking for another job. If that's the case, they might go that way. But for me, I feel like the willingness to learn more and be adaptable is more of a long-term need and going to fit well and fit better with your team.
What is your biggest motivation in this job?
My biggest motivation? I mean, I do enjoy solving problems. But, the irony of that is there have to be problems, and problems are stressful. So, I mean, my biggest motivation is at the end of the day to just be happy that I felt added value, felt that I figured out what was going on and how to make something do what we wanted it to do and see it do that. And it's funny because it's like, what's your motivation? It really comes down to seeing something to completion. Although, as we all know, things are never really fully complete. With software development, it's a long sort of cycle. I mean, things can be broken down, yes, and you can have these little moments of, yay, I got that done. Yeah, I got that done. But in my personal experience, one of the I'll do this analogy. I love to just mow my grass because I see, hey, the grass is way too big. I want to cut the grass to make it not so big. I can go out there in an hour. I've cut the grass. I can look at it. It's done. Wow, that's a pleasure for me. Being able to say I did that and it looks nice. Yay. Software development, you might wait like long periods of times to see some sort of return on what you've done. And it's basically because of just the inherent nature of things always changing. You never quite feel that things are done. Um, so, I mean, what motivates most people is it feels good.
Yeah.
So,
So by creating value, it's like an eternal challenge because you know that even if you've solved a problem today, there are going to be more tomorrow, day after tomorrow,
yeah,
whenever. It just never ends, and you just get you learned how to fuel and get the adrenaline from the actual process.
right. And I mean, honestly, too, I feel like throughout this whole career, if there are things that I have learned along the way, things that my experiences might help other people as they go through it. Um, I mean, this is clearly long game because I've been doing this for 29 years, but if anything I've said here today helps someone decide whether or not they want to, continue a career in this space, and what to look out for, what to think within themselves, then that'll that motivates me that I might be helping some people.
For someone who's starting out, how would you how can one understand that he's actually sufficient and he knows enough to get a developer job?
I think
I
that's
know it is a broad question.
yeah. I don't know. I think that's really just specific to that individual as to how confident they feel about taking that step. And sometimes you just have to take it and fail or succeed and be happy with that outcome, and evaluate after. After that either first failure or first success. Uh,
It's just if you look at the job descriptions now, the things that you have to know and do to get a junior job is
it's
sometimes,
daunting.
yeah. There are different programming languages. They vary depending on the use. What is your most favorite programming language and why?
I mean, I've worked with C most of my life, so it's hard to say because it's C, C++, or Go. And Python I've worked with. I mean, I did enjoy Python aspects of it with just the interactiveness of it. Being able to get a result as you type is pretty cool. Go, I think, has been, for me, the most fun. Not only because it's something new, but it's just the way in which you can write the code and test it simultaneously with the platform, and handle things concurrently, and some of the aspects of that language and the things that they have thought about, like you don't have to worry about memory management as much and pointers, which can really be problem and pitfalls with your C code. So there's garbage collection that's done for you. You don't have to manage it in your head as you go about writing your program. So those are things that I like about Go.
Do you think that a starting out person, unless he loves C, do you think that people need to learn C just for?
It's not. It's still there. It's still out there. So, my opinion would be having that knowledge actually would be helpful even to a younger engineer because it's just so embedded in everything.
Does artificial intelligence impact your job today?
Today, no. In the future, probably. Yeah.
Did you use it for code?
No, I have not used the AI for code, but I know that ability is available. I think its applications right now aren't um, aren't tuned yet as much as needed in order to do the development that we make. But I can foresee in the future that it's possible. Only because it's a lot of patterns, recognition of patterns. So even with problems that we solve, we typically have models that we follow in implementing certain things. So those models could easily be, I think, rendered in some type of AI, which would produce code.
Would you say that understanding electrical engineering or hardware, the concept of how those things work, is not important for people who learn how to code now?
I wouldn't say it's not important, because any software needs to run on some platform. And there are certain aspects of programming in a versatile way for your code to be able to run on any platform that might need to be considered, such as memory and processing speeds. So it depends on your application. If what software it is you're developing is going to be running in an embedded system space, then yes, absolutely. If it's going to be something that's very highly scalable and put out into the cloud and managed as far as those deployments and scale up and scale out by something else, not so much. But it depends on the application.
For young professionals who want to become a developer themselves, what advice would you give to those people now?
Just hold on, hang on there. And, if this is something that you are passionate about doing, continue doing it and learning and asking for questions, going to people for help, seeking out from your peers things that you guys can do to, learn how to program better, make up your own programs. Think about applications, organize things, break things down,
Solve problems.
solve problems. Yeah.
Shane, you are an amazing person. Thank you for your time.
Thank
It was
you
a
for your
pleasure
time.
talking to you today.
It was a pleasure for me too. Thank you.